Hello students, I am Pragyan from Deepal School. Today we will discuss electrolysis part 2. Last video we have discussed electrolysis part 1 where we have discussed this introduction, some terms related to electrolysis. Then we have discussed this mechanism of electrolysis. Today next part we will discuss this electrochemical series, selective discharge of ions and some examples of electrolysis. So let us now discuss this electrochemical series. So it is a first of all in class 8 onwards class 9 we read that one. It is a metal activity series. Here the new term we will use electrochemical series. So we have in metal activity series we have sodium, potassium, calcium, magnesium, aluminum, like this all this, and gold, platinum will be at that last. But here you see these are which are it is most reactive, those are placed at the top and of that activity series, and which are it is decreasing, this reactivity decreases, and lower we are getting least reactive series. So these are more reactive means they can lose electron easily and they can form ions easily. Okay, but here if you will go, they will with much difficulty they will produce ions, lose ions. Okay, here copper also with much difficulty it will form ions. But so this now we are going for the another term which is known as electrochemical series. In this electrochemical series we will have two parts. One will be this for these cations and another one will be for anions. Okay, so what are cations? Which are the positively charged ions are cations. Last class we have discussed, and all those are usually metals along with hydrogen. We are getting all these are cations. So those are placed like this. We can say K plus, Ca2 plus, Na plus, magnesium 2 plus, aluminium 3 plus, zinc 2 plus. So all these are there. Then we'll go for hydrogen plus, copper 2 plus, mercury plus. We are going like this. So here the arrangement is so done that the elements that ionize more readily, means see that one is potassium, it can ionize more readily because it is more reactive. Discharged with greater difficulty. Discharge with greater difficulty means what? We are discussing electrolysis. Here in the respective electrodes these ions will get discharged, but it says that one which is at the higher position will discharge most difficultly and which is at the lower position will get easily discharged. So out of copper and silver we can take this one. Silver get discharged easily at the respective electrode or cathode rather in comparison to copper. Here usually we get question, this is board question, discharge more readily and more difficulty. That options will be given. This one it can be arranged, this one increasing order, decreasing order, otherwise can be in the multiple choice question also you can get such type of question. And here for example, Fe2 plus, copper 2 plus, H plus it is given to us and it is asked discharge more readily. Readily, which can be discharged more readily? See here, one will be copper, the another one will be H plus. Where is copper position? Copper position is here. H plus position is here. This one iron position will be here. So out of this, who will be more discharged easily? So copper will discharge more readily. With much difficulty, which one will be much difficulty? This Fe2 plus will be much difficulty. Like that, SO sulfate, bromide, then NO3 minus nitrate and OH minus we are taking. So in this case readily which one will be discharged? So OH minus will readily discharge. See, this is the position we are taking: sulfate, nitrate, chloride, bromide, iodide and OH minus. OH position is the lowest one. See, nitrate position is here, bromine position is here, sulfate it is the highest position, that is it has no chance. So here we are getting more readily OH minus, it was this one will be readily, and here sulfate this one will be difficulty. So while attending the question you see that one what is the question given, whether it is given readily or it is given difficulty. Okay, so this is part of this electrochemical series. Then we will go for selective discharge of ions. So this other name of selective discharge of ions is preferential discharge of ions present in the electrolyte at the respective electrode. Here we are preferring which one will be there. For example, I am taking copper sulfate, aqueous copper sulfate I am taking. So here when this one will dissociate, copper 2 plus, sulfate 2 minus, and here for H2O this one will be H plus and OH minus. So for anode, who will go for anode? Anode negative will go for anode. So sulfate 2 minus, OH minus will be there for anode. And for cathode, we will have copper 2 plus and H plus. So we have to select that one, which one will move toward the respective electrode. This is known as preferential discharge of ions present in the electrolyte at the respective electrodes. Which one will move? So what are the factors affecting the selective discharge of ions? So first factor will be the relative position here, relative position of the ion, cation or anion ions in the electrochemical series. Second one, what it can be? Concentration of ions in the electrolyte. Third one, what it will be? What is the nature of electrode? We will discuss now one by one. So relative position we will discuss. So first one will be relative position of ions. So now let us see that one. This will be the same example what we had taken earlier. We will take this one. It can be your this one will be copper sulfate solution. Let us take again. Okay, so again let us see that one. We are getting copper 2 plus SO4 2 minus, and here water, it give rise to H plus, it give rise to OH minus. So now we will discuss which one will get preference to discharge at the respective electrodes. This one for cathode. Yes, this one is for anode. Now let us see that one at cathode. Who will move towards cathode? So here relative position, previously we know that one, this lower in the electrochemical series will get the preference to discharge. So here out of these two, copper and H plus, here copper is here and hydrogen is here. So which one is the lower? Copper is the lower. So copper will get a chance to discharge. So here out of this one at a cathode, copper 2 plus, as it is plus it is given, it will gain 2 electron to become copper. Understood? And here H plus will not get a chance because copper is below to hydrogen. Then at anode, who will be? We have sulfate and we have OH. See that one? Here is your OH, here is your sulfate. Which is the higher position? Yes, sulfate is the higher position. Which is the lower position? OH is the lower position. So OH will get preference to discharge. So OH minus, it will lose again electron, becomes OH, and for such OH will give rise to water and oxygen. Understood now how it will be? So this one is the relative position of ions in the electrochemical series. Then we will go for the second option, that is the concentration of ions in the electrolyte. Okay, so for concentration of ions in electrolyte, we will divide into two parts. We will take dilute NaCl solution and we will take concentrated NaCl solution. Okay, so solution, I have taken solution word. It means that water is the essential part of it. So again let me go for electrolytic dissociation reaction. So this one NaCl, this symbol is must, Na plus, Cl minus, then we will go for water. This one will be H plus plus OH minus. Okay, so here this dilute NaCl solution, obviously the concentration of Na plus and Cl minus is lower in comparison to water. That is why it is dilute solution. The definition of dilute, that one, it will be amount of solute is less in the solution. So here let us go for that reaction. At cathode, who will move towards cathode? Out of this H plus and Na plus, this concentration of Na plus is less. That is why hydrogen will move towards it. So H plus plus electron will give rise to hydrogen, and this is hydrogen atom. It cannot be in that atomic state. So this one will be hydrogen. Anode reaction will be, who is in here? OH, it will be, the concentration of OH will be more. So OH minus, minus 1 electron give rise to OH. For such OH give rise to water and oxygen. So what is liberated at a cathode and what is liberated at anode? So question can be asked, name the gas which is released at cathode and at anode during the electrolysis of dilute sodium chloride solution. Dilute sodium chloride solution. Understood? So answer will be gas at cathode will be hydrogen, gas at anode will be oxygen. This one it is important for us. Then let us go for concentrated. Okay, so we will have concentrated NaCl solution. So here the same thing also we will go here. NaCl give rise to Na plus Cl minus, and H2O will give rise to H plus OH minus. Here what it is concentration? Obviously Na plus concentration is more in comparison to hydrogen. Cl minus concentration is more in comparison to OH. But here let us see that one, who is discharging at cathode. So for cathode, two participants are there, the two competitors are there, but out of this one, the position of sodium is much higher in comparison to hydrogen. That is why sodium will never get a chance in that aqueous solution to get discharged at their respective electrode. So what will get now? Hydrogen will gain one electron, will become hydrogen. H plus H give rise to H plus. And here for anode, who will move toward anode? Obviously the concentration will be Cl will be more, and here the position of this Cl minus and OH minus also not that much difference is there. That is why we can take Cl minus electron will give rise to Cl, Cl plus Cl give rise to Cl2. So in this case, what is the gas released here? Gas at cathode will be hydrogen, and at anode will be chlorine. Remember. So here I am taking another example. Let me give you here molten NaCl. These three are different things. So I am taking molten. Do you think that one here solution or water part will be there? No, water part will not be there. So here I can say NaCl. So it can give rise to Na plus Cl minus. So at cathode, who will move towards cathode? Only one is there, Na plus electron give rise to Na. And at anode, this one will be Cl minus electron will give rise to Cl. So this one will be Cl2. So only remember, in case of molten NaCl only we can get sodium, not from any aqueous solution. So this is for this concentration of ions. Then the most important we will take, that one is the nature of electrode. So nature of electrode here, nature of electrode. In this case, what we can have, nature in this depending on reaction, depending on taking part in reaction, we have two type of electrode. One is your inert electrode, another one is active electrode. But here this one, it is previously we had discussed anode cathode, that is depending upon the charge, positive negative. But here how these are taking part in the reaction or not, inert reactor and active reactor. Inert, it is do not take part, but active, it takes part in the reaction. What is the inert reaction? It can be platinum, it can be your carbon. Okay, so graphite, carbon, or it can be your graphite, then it can be your iron. Then in case of active electrode, it can be copper, then it can be nickel, it can be silver. All these things can be active electrode. Okay, depending upon this one, we will take another here. So here we will take copper sulfate solution. Here also we will take copper sulfate solution. But here electrode we will take as the platinum electrode. Platinum electrode. Here we will take copper electrode. Okay, now let us see. And one thing remember, when we are talking about active electrode, this active electrode we mean to go for anode only. Okay, this one you remember. So copper sulfate solution, I am taking copper sulfate solution. So what is that electrolytic dissociation? Copper 2 plus, sulfate 2 minus, water, this one will be H plus plus OH minus. Here what is the electrode I have taken? Electrode I have taken cathode. Cathode I have taken as copper electrode, and anode I have taken as platinum electrode. So reaction at cathode, what it will be? Who will move towards this one? So obviously copper 2 plus 2 electron, this one will be copper. And at anode, what will be reaction? This one will be OH minus electron give rise to OH. For such OH will give rise to water and oxygen. So here we are getting copper. So copper will get deposited at cathode. And what is the observation here? This observation is that it is the pinkish brown metal get deposited. And what will you take this electrolyte? Electrolyte, here blue color fades, means it turns towards this colorless. But in case of copper sulfate solution, using that copper electrode, let us take. So today now we will discuss this copper sulfate solution taking the copper electrode. The same reaction will be there, electrolytic reaction. Then what will be taken as cathode? Cathode is taken as copper and anode is taken also as copper. Here we are taking this one as the active electrode because copper is going to take part in the reaction. So this out of copper 2 plus and H plus, obviously copper the position is the lower, that is why copper will discharge. But in this case OH minus and sulfate ion both will rush towards this anode, but no one can discharge. Rather this anode will take part in the reaction. It will lose 2 electron and it will become copper 2 plus. So here take this one, copper, it will lose 2 electron and it will become copper 2 plus, and this one again will go there to cathode. So at the end of the reaction, this anode will decrease in mass and this cathode will increase the mass, and blue color does not fade. Blue color of electrolyte does not fade. Okay, so for today this much. Next video we will discuss about these examples.